Yes, negative or positive forced or induced draft ventilation can be used to reduce the classification of a hazardous area. According to the National Electrical Code, specifically Article 500.8c in the 2020 edition, ventilation is a recognized method for mitigating the risk of explosion or fire in Class I, Division 1 locations. This section of the code addresses the use of ventilation to reduce the concentration of flammable gases or vapors to a level where the area is considered less hazardous, potentially making it suitable for equipment and wiring methods approved for Division 2 or even unclassified areas. The fundamental principle is that by continuously diluting and removing flammable substances, ventilation prevents the formation of explosive mixtures. However, successful implementation relies on careful design and adherence to specific requirements. The ventilation system must maintain a safe atmosphere under all normal operating conditions. This means that the system's capacity must be sufficient to handle the expected rate of release of flammable substances. Factors such as the volatility of the substance, the size of the potential release, and the geometry of the space all influence the required ventilation rate. Furthermore, the design must also consider any anticipated failure conditions. This is a critical aspect of the ventilation system's reliability and safety. Potential failure scenarios include, but are not limited to, fan failure, duct blockage, and loss of power. The system should be designed to either prevent these failures or to mitigate their consequences. For example, a backup power supply may be necessary to ensure continuous operation in the event of a power outage. Redundant fans or automatic dampers may be required to maintain airflow if a fan fails or a duct becomes blocked. The type of ventilation system, whether negative or positive pressure, also plays a significant role. A negative pressure system extracts air from the hazardous area, creating a vacuum that prevents flammable vapors from migrating to adjacent areas. This type of system is often used when the primary concern is to contain the hazardous atmosphere. A positive pressure system, on the other hand, introduces clean air into the hazardous area, diluting the concentration of flammable vapors. This type of system is typically used when the goal is to protect equipment or personnel within the area. Regardless of the type of system, the air intake should be located in a clean air source away from any potential sources of flammable vapors. The exhaust should be directed to a safe location where the diluted vapors can be dispersed without creating a hazard. It's important to note that the effectiveness of a ventilation system depends on proper installation and maintenance. The system must be installed according to the manufacturer's instructions and all applicable codes and standards. Regular maintenance is essential to ensure that the system continues to operate as designed. This includes inspecting and cleaning fans, ducts, and filters, as well as testing the system's airflow and pressure. It is crucial to consult with a qualified professional to design and install a ventilation system for hazardous locations. These professionals have the expertise to assess the specific hazards of the area, determine the appropriate ventilation rate, and select the right equipment. They can also ensure that the system complies with all applicable codes and standards. In addition to the general requirements outlined in Article 500.8c, the National Electrical Code contains specific requirements for ventilation in different types of hazardous locations. For example, Article 502 addresses ventilation in Class Roman II locations, which are areas where combustible dust is present. Article 503 addresses ventilation in Class Roman III locations, which are areas where ignitable fibers or flames are present. These articles provide detailed guidance on the design, installation, and maintenance of ventilation systems in these specific types of hazardous locations. Furthermore, it is essential to consider the interaction between the ventilation system and other safety systems in the area. For example, the ventilation system may need to be interlocked with fire detection and suppression systems to ensure that these systems operate effectively in the event of a fire. The ventilation system may also need to be interlocked with process control systems to prevent the release of flammable substances in the first place. In summary, the use of ventilation to reduce the classification of a hazardous area is a complex issue that requires careful consideration of several factors. The design and installation of the ventilation system must comply with all applicable codes and standards, and the system must be properly maintained to ensure its continued effectiveness. It is always recommended to consult with a qualified professional to ensure that the ventilation system is designed and installed correctly. The application of ventilation for hazardous area classification reduction is not a one-size-fits-all solution. It demands a thorough understanding of the specific hazards, the applicable regulations, and the engineering principles involved. The goal is to create and maintain a safe working environment where the risk of explosion or fire is minimized. The NEC Article 500.8c provides the framework, but the details of implementation are highly dependent on the particular circumstances of each application. In addition to the technical aspects, it is crucial to have a robust safety management system in place. This system should include procedures for identifying and assessing hazards, controlling risks, and monitoring the effectiveness of safety measures. The ventilation system should be integrated into this overall safety management system to ensure that it is properly operated and maintained. Employee training is another essential element of a successful hazardous area safety program. Employees who work in or around hazardous locations should be trained on the hazards present, the safety procedures to follow, and the proper use of equipment. They should also be trained on the operation and maintenance of the ventilation system. Regular audits and inspections should be conducted to verify that the ventilation system is operating as designed and that all safety procedures are being followed. Any deficiencies identified during these audits and inspections should be promptly corrected. Furthermore, it is important to keep accurate records of the ventilation system's performance, maintenance, and inspections. These records can be used to track trends, identify potential problems, and demonstrate compliance with regulations. The use of ventilation to reduce hazardous area classification is a powerful tool, but it is not a substitute for other safety measures. It should be used in conjunction with other engineering controls, administrative controls, and personal protective equipment to create a comprehensive safety program. For example, the use of intrinsically safe equipment can reduce the risk of ignition in hazardous locations. Administrative controls, such as hot work permits, can prevent activities that could create a spark or flame. Personal protective equipment, such as flame-resistant clothing, can protect workers from the hazards of a fire or explosion. In conclusion, ventilation can be a valuable method for reducing the classification of hazardous areas, but it must be implemented carefully and in accordance with all applicable codes and standards. A comprehensive safety management system, employee training, regular audits and inspections, and accurate record keeping are all essential elements of a successful hazardous area safety program. Consulting with qualified professionals is crucial to ensure that the ventilation system is designed, installed, and maintained correctly. By taking these steps, organizations can create a safer working environment for their employees and reduce the risk of accidents and incidents. Always prioritize safety and seek expert advice when dealing with hazardous locations. The information provided here is for general guidance only and should not be considered a substitute for professional engineering advice. The specific requirements for ventilation in hazardous locations may vary depending on the jurisdiction and the specific application. It is essential to consult with local authorities and qualified professionals to ensure compliance with all applicable regulations. Remember that safety is everyone's responsibility. By working together, we can create a safer working environment for all.